So acid, alkali, and salt. We were discussing the reactions of acid. The first reaction we discussed was when acid is reacting with metal. This gives salt and hydrogen. The second reaction is when metal oxide react with acid. This result in a formation of salt and water. The third reaction we discuss metal carbonate. Was reacting with acid. This result in a formation of salt, water plus carbon dioxide. And the fourth reaction, when alkali is reacting with acid, this result in a formation of salt plus water. So these are the reactions we discuss, and all these reactions can be used to prepare the salts. You can see all of them result in a formation of a salt. We discuss how we prepare salt from 3 of these reactions. The last reaction now we'll discuss how it is done and how we can prepare a salt from the last reaction. Acid plus alkali. Last time only I discussed how to write ionic equation and completing equation, but now how to obtain a salt. So example, the fourth reaction, which is acid is reacting with an alkali. This result in a formation of salt plus water. So if equation is there, acid such or sodium hydroxide is react with sulfuric acid. So sodium hydroxide is reacting with sulfuric acid. What will be the product? Sodium hydroxide, alkali reacted with sulfuric acid. What will be the result or the product of this reaction? So it will give sodium sulfate plus water, because if it's a sulfuric acid, then sulfate salt will be there. So result in a formation of sodium sulfate plus water. This is a word equation. If we want to write symbolic equation, so sodium hydroxide is NaOH. Sodium is group 1, so +1, and hydroxide is -1, so that's why NaOH. Sulfuric acid is H2SO4. This result in a formation of sodium sulfate. So sodium sulfate formula, how to work out the formula? Sodium belongs to group 1, so it's +1, and sulfate molecular ion with a valency or a charge of -2. So formula for sodium sulfate will be Na2SO4 plus water is there, so H2O. This is a symbolic equation, but symbolic equation must be balanced as well. So for balancing, this is first we complete, then for balancing, we start with oxygen, followed by hydrogen, and then other elements. So when we start with oxygen, oxygen on our left hand side 4 + 1 5, on the right hand side 4 + 1 5. Oxygen is balanced. What about hydrogen? Hydrogen is, we have 2 hydrogen here, and we have 2 + 1 3 hydrogen here. So it shows that the hydrogen is not balanced. So how we can balance hydrogen? Because other side, this side we have 3 and this side we have 2. So if I try to balance, if I put 2 here, what it make? It make 4 hydrogen on the right hand side, but 3 hydrogen on the left hand side. So that's why I will put 2 here as well. Reason, so that I will have 4 hydrogen both side. You can see this 2 multiplied by hydrogen, that's 2, and then this 2 is there. So makes 4 hydrogen. So before placing any number, I was having 3 hydrogen on the left hand side and I'm having 2 hydrogen on the right. So the side where we have less number of hydrogen, we'll put the number. So example, if I put 1 is already there. So if I put 2, that 2 makes 4 hydrogen. So I have to make 4 hydrogen. So to make 4 hydrogen, I will put 2 here. So it makes 4 hydrogen both sides. So hydrogen is balanced. Then oxygen is already balanced. You can see 4 into 6, 4 into 6. Sulfur, we have 1 sulfur here, 1 sulfur. Sodium 2, sodium 2. So you can see this equation, when I try to balance hydrogen, this equation is balanced with all the other elements. So this is a symbolic equation. We start balancing with oxygen followed by hydrogen at the last other elements. The state alkalis, because soluble aqueous, acids aqueous. Most sulfates are soluble except barium, calcium, and lead. They are insoluble. So this is a soluble sulfate, and water is in a liquid state. If you want to write an ionic equation, so what we do, we cancel out the common ion in aqueous substance. So if we want to cancel out the common ion in aqueous substance to write this ionic equation, so first if I will write the balance symbolic equation, because you should have a balanced symbolic equation to write an ionic equation. So the state symbols aqueous, 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 liquid. So we highlight the substance which is aqueous, so sodium hydroxide aqueous, sulfuric acid aqueous, sodium sulfate aqueous. Now we cancel out the common ion in aqueous substance. So which ion is common? Sulfate ion is common, so we cancel sulfate ion. Sodium ions are also in aqueous, so we cancel sodium ion. So what we are left with? We are left with 2 hydroxide ions, and we have 2 hydrogen ion, and this will result in a formation of 2 water molecules, 2H2. So this is the ionic equation, and I told you whenever acid and alkali reaction is there, the ionic equation is always H plus OH, or OH plus H gives H2O. Is it clear? So first one is a word equation. Then second one is a symbolic, and the third one is a ionic equation for reaction between acid and alkali. Now, if we want to prepare salt by this reaction, so if we want to prepare salt by this reaction, the difficulty here, what is the difficulty? Acids are aqueous and they are also colorless, no color. Alkalis are also aqueous and they are also colorless. So if two colorless substances are mixed together, like example, if I have in one container, I have acid and another container, I have alkali. Both are colorless. I just use the shade here to just I show how it is done. But both of the solutions are colorless, no color. So if acid and alkali, if both are colorless, and if I mix them together, how I will know that, how I can identify whether acid is in greater quantity or alkali in greater quantity? We cannot identify. Why we cannot identify? Because both of them are colorless, no color. So we don't observe anything when this reaction occur. When acid reacted with alkali, if either acid is more or alkali is more, we cannot identify what volume of acid can react with an alkali. So for this purpose, we cannot directly add this. We cannot do this method. So what we use a technique to know how much acid can react with alkali, and this technique is known as titration. So the technique which we use to identify how much acid reacted with an alkali or how much alkali will react with acid, that technique is known as titration. So how we carry out this titration? Practically how titration is done. So example, you have this conical flask. So this is a conical flask, and what we will do, this is a pipette. We use pipette and fill the pipette with acid, and we transfer this to a conical flask. This is how titration is done. Titration is a technique which is used to identify how much acid is reacting with an alkali. So for this titration, first what we will do, we add about 25 cm cube of acid in a conical flask. So this is a pipette, and using this pipette, we transfer acid to a conical flask. But this apparatus, this pipette, there are some advantages of using a pipette, and there is a disadvantage also. What is the advantage? The advantage is that the pipette is accurate in measuring 25 cm cube, because pipette will have only one label. I will show the complete picture of the pipette. So pipette is having only one label, so it is accurate to measure 25 cm cube. But what is the disadvantage of using a pipette? The disadvantage of using a pipette, it takes time to transfer the solution. An advantage is that it will be accurate, because the pipette is having only one marking or one mark on it, so it will be accurate in measuring 25 cm cube. So first what we will do, we'll fill the pipette with 25 cm cube of hydrochloric acid, and we are transferring that. So you can see here the solution is transferred, but it is taking time to transfer 25 cm cube. Then we are adding an indicator. What indicator we are adding here? We are adding phenolphthalein. Why we are adding phenolphthalein or indicator here? Reason for that, because indicators show a color in acidic and alkaline medium. Phenolphthalein is colorless in acidic medium, so we will use a dropper and we add drops of phenolphthalein here. Why? As you can see, even the conical flask is shaken here, still the color, it does not show any color, because phenolphthalein is colorless in acidic medium. Then we have sodium hydroxide. This is and this one is a burette. So we fill this burette with sodium hydroxide. And you can see here for burette, the numbers, how the numbers are written: 0, then 1, 2, and between 0 and 1, between, like if there's a 0 mark and then there's a 1 mark, so there are further divisions. What are these divisions? Each mark stands for 0.1. So burette is accurate to measure. Burette can measure accurately 0.1 centimeter cube. So we fill the burette with an alkali, and now you can see a flask. This is a conical flask which was initially filled with acid and indicator. Then we are adding alkali from the burette. The moment we are adding alkali from the burette, because phenolphthalein is pink in alkaline solution. But what happened, as you are adding alkali, because alkali initially did not react with acid, that's why it show a pink color. But when you shake this flask, the pink color will disappear. Why the pink color will disappear? You can see here the pink color disappear, pink or purple, but pink is there. So why this color disappear? Because it shows that the moment when you add alkali from the burette, so that alkali initially did not react with acid, that's why it was pink in color. But as the alkali reacted with acid, so alkali molecules used up, so now solution is still acidic. As the solution is still acidic, on shaking the conical flask, it will turn into colorless. And you will do this process, you will continue this process. Like you can see, when a drop is added, it show a pink color. Why it is showing a pink color? Because it means that alkali molecules are added. And why the color disappear? It shows that the alkali molecules reacted with acid and still you have acid in the conical flask. You can see here continuously adding like drops of alkali, and if the solution shows like remain colorless, it means still we have acid. But when all of the acid used up, and it should be drop by drop, so for accuracy, otherwise if you add too much alkali, this it will not be accurate. So it's like we add drop and we are swirling the mixture so that it will disappear, or it shows that their reaction occur. But when all of the acid is reacted with an alkali, if you are not left with, like all of the acid is used up, and even when you swirl, like the pink color will not disappear. The reason to have a white paper here at the base is so that we can easily recognize the color change. White background is easy to recognize the color. So now you can see the solution turned pink. So what it shows? What it shows that the solution is not changing its color. It means now this solution is alkaline. So how you will know how much acid and alkali reacted? So first, how much acid we took? We took 25 cm cube of acid. And then for alkali, how we will know how much alkali is used? So for using or identifying how much alkali is used, so we know the first volume in the beginning it was 0. We use the lower meniscus, and after some time, when the acid completely reacted with an alkali and we are left only with alkali or alkaline solution, we'll read the volume again. Example, the volume is 10.1. So how much alkali is required for this reaction? It required 10.1 cm cube of alkali. So then you will read the scale for a burette. So what it shows acid reacted with an alkali and solution is alkaline. So how to know? You can see this is a burette. So we read this burette. So each is representing 0.1, like this is 23, 23.1, 23.2, 3, 4, and 23.5, and so on. So what is the level here? We always read the lower meniscus. So this is 25, 25.1, 25.2, 25.3, and 25.4. So what is the volume of alkali in this experiment used? It is 25.4 cm cube. So we identify what volume of acid is reacting with an alkali using this technique, which is known as titration. Is it clear, the concept of titration? Any doubt in this? So what we do here, we reacted acid with an alkali. So in the beginning, we have a conical flask and a beaker which is filled with acid. You can see acid is colorless. So we fill the pipette with acid and transfer into conical flask. But if they ask what is the advantage of using a pipette here, it is accurate. What is the disadvantage? It takes time to transfer the solution. What is the advantage of using a conical flask? Conical flask, it is easy to swirl or mix the solution compared to that of beaker. You can see here, as acid and alkali were reacting, so we have to shake or mix the content so we can easily swirl the mixture. Then we will add indicator. In this experiment, we add phenolphthalein. Phenolphthalein is colorless in acidic medium, so that's why the solution will remain colorless. Then we fill the burette with an alkali. We fill to a 0 mark, and then we add alkali from a burette. And when we add alkali from the burette, acid is reacting with an you can see acid first. When we add alkali, the indicator is present, so indicator shows a pink color if there is a presence of alkali. But as we swell the mixture, the alkali molecules reacted with acid and still we have acid more. That's why the solution will turn colorless. But moment all of the acid is used up, this color shows that this region you have alkali molecules. But when you swirl the mixture, all alkali molecules spread out, so they reacted with acid and it's used up again. But once the solution, all of the acid used up, then no more color change will occur. As no more color change will occur, so that it shows that all of the acid is used up and now you have more alkali. So now we identify, because there is no color change, it means all of the acid used up and we have alkali. We know what volume of acid was there, and using a burette we'll identify what volume of alkali is used, and using their volumes we can repeat the experiment and prepare the salt. Any doubt in this? So how we can prepare the salt by this technique or this method? So how to prepare salt by this method? So first what we will do, we will use a titration to identify how much acid react with alkali. And in this one, you have to explain titration in detail. Like you have to mention the points of titration. So first what we will do, we will fill acid by pipette or take 25 cm cube of acid by help of pipette and transfer into conical flask. So we took 25 cm cube of acid by the help of a pipette and we transfer into conical flask. Here, instead of pipette, you can also use measuring cylinder. But if you use measuring cylinder, again, there's one advantage and disadvantage. Measuring cylinders are disadvantage is that it's not accurate. And advantage is that it can transfer quickly. So what is the advantage of pipette? Pipette is accurate, but what is the disadvantage of measuring cylinder? It is not accurate. And what is the disadvantage of pipette? It takes time. And what is the advantage of measuring cylinder? It transfers quickly. So you can either use pipette or measuring cylinder, any one of them. Then you will add drops of indicator. Add few drops of indicator. You have to specify the indicator, which indicator you are using. But the best indicator for titration is phenolphthalein. Why it's best indicator? Because other indicators show a transition of a color, like it may change from green to blue. It may change from red to violet. It may change from red to blue. So there's a transition of a color, but in case of phenolphthalein, it is colorless, change to pink, so it's easy to recognize or identify. So add drops of indicator and mention the name of indicator. Like here we are adding phenolphthalein. So add drops of indicator, which is phenolphthalein. You can also mention methyl orange. It can also be used, but for a practical reason for using phenolphthalein or preferring phenolphthalein over other indicator, because phenolphthalein is colorless and change to pink. But other indicators show a transition of a color. Like example, changes from red to yellow, red to orange, red to green. So it shows a transition. So it's difficult to identify when all of the red color changes to green or red color change to orange. But other indicators can be used. Only drops of indicator is added, like 1 or 2 drops enough, not too much. By using a dropper, we add drops of indicator. Then fill the burette with alkali till 0 mark. Then add alkali to conical flask until indicator show a color change. So when the indicator will show a color change, that time you will indicator is added to add drops of indicator or phenolphthalein to conical flask. Contain acid here. Then fill the burette with an alkali till 0 mark. Add alkali to conical flask until indicator shows a color change. Then record the volume of acid and alkali reacted. Like as we know, 25 cm cube of acid was there and how much alkali is reacted. But we want to prepare a salt. So to prepare a salt, like example, as you can see here, this is a colored solution. So if this is a colored solution, so I cannot obtain a salt from this solution. Why I cannot obtain a salt from this solution? Because if I try to obtain a salt from this pink solution, the crystals will be pink in color. So I cannot obtain directly the salt from this solution. So what we do, if we want to obtain, so we repeat the experiment. Then we repeat this experiment with same volume of acid and alkali without indicator to obtain salt by crystallization. So why I did not use the same solution? Because if it was having indicator, the solution will be a colored solution, and obtaining a salt from colored solution, it will make colored crystal. So example, you was having acid, you was having 25 cm cube of acid, and the alkali example, say 20.3 cm cube of alkali was there when the indicator show a color change. So what you will do, you will repeat the experiment, the whole procedure without indicator. Like fill up the conical flask with 25 cm cube of acid and add 20.3 cm cube of alkali, and then obtain a salt from that solution, because 25 cm cube of acid completely reacted with 20.3 cm cube of alkali. Is it clear? This whole experiment, how to obtain a salt by this technique, acid react with alkali. So first, acid react with alkali cannot be done without indicator, without titration technique, to know how much acid reacting with an alkali. And then when you know acid reacted with an alkali, you can obtain a salt from a mixture. Yes, that is true, Mohsin, that in practical, a solution is alkaline, but you can see there were drops were added. Like it will be alkaline, but not too alkaline. You can see we are adding drop wise, like one drop at a time, and swirling the mixture. So when the indicator is not showing a color change, it means the solution is alkaline. But in practical, it's a slightly alkaline, not too much alkaline, because you added
Yes,
a drops. Yeah.
so it's negligible. So we don't
It's
negligible.
negligible.
So we don't.
Yeah, it's negligible. That's why we consider that what volume of alkali was used to show a color change, that is the amount. That's why it should be added drop by drop, not just open the tap and observe a color change. It should be drop by drop for greater accuracy. Is it clear? This experiment to prepare a salt by this method. So these
Yes,
are
sir.
the, so we discuss methods of preparing salt for reaction of acid. You can take the screenshot, so I will move on. So first three methods, when acid was reacting with metal, metal oxide or metal carbonate, similar method was there to prepare a salt. But when acid react with an alkali, because two are the solutions, so as two of them are solutions, So we use a technique titration first to identify the volume of acid reacted with an alkali, and using titration, we use this technique to know what volume of acid reacted with an alkali, and we'll repeat the experiment without indicator to obtain a salt from that solution. So if we want to prepare a soluble salts, method of preparing soluble salt. So techniques or methods which we use to prepare soluble salt, all the reactions of acid. So what are the reactions of acid? Acid plus metal. Acid plus metal oxide. Acid plus metal carbonate. And acid plus metal hydroxide. So these are the techniques, the metal hydroxide, or you can also say alkali. So when acid is reacting with metal, acid is reacting with metal oxide, acid is reacting with metal carbonate, and acid is reacting with metal hydroxide. So this will result in a formation of salt and hydrogen. This will result in a formation of salt plus water. This will result in a formation of salt plus water plus carbon dioxide. And this will result in a formation of salt and water. So these three techniques are similar to prepare a salt, and this one we use titration. So in these techniques, what we use to carry out, we have a container which is filled with acid, and we add a solid to it. It can be metal, it can be metal oxide, it can be metal carbonate. And then we filter the unreacted and do crystallization. But here we use a technique of a titration. We use a burette and we use conical flask. So we use a conical flask, burette and pipette to know how much acid is reacting with an alkali. Is it clear? Any doubt in this preparation of the salt, soluble salt, by these techniques? You have to learn the word equation, symbolic equation, ionic equation, the technique to prepare salt in this part. Any doubt in this?